Sound intensity. Understanding sound intensity at different points from a source. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Firstly, let me teach you that what is sound intensity. Well, consider a source producing some sort of sound. We know that sound spreads over a larger and larger surface area as it moves away from the source. Now let's consider this sheet. Sound waves or sound energy can hit or pass through this sheet. Let the area of this sheet is 1 meter squared. Here, I am interested that how much sound energy reach or pass through this 1 meter squared area in 1 second. Let me repeat it. I am interested that how much sound energy reach or pass through this 1 meter squared area in 1 second. Thus, we define sound intensity as sound energy passes through 1 meter squared area in 1 second is called sound intensity. Let me repeat it. Sound energy passes through 1 meter squared area in 1 second is called sound intensity. Sound intensity is denoted by I. Mathematically, we write it I is equal to E upon A into T, where E is the sound energy that passes through unit area or 1 meter squared area A, and time T is equal to 1 second. What about the SI unit of sound intensity? Well, we know that the SI unit of energy is joule. The SI unit of area is meter squared and the SI unit of time is second. So the SI unit of sound intensity is joule per square meter per second. We can also write another equation of sound intensity in terms of power. For example, we know that power is energy or work done per second, or P is equal to E upon T. Now, instead of this E upon T, we will plug in this equation as simply the power. Thus, we get I is equal to P upon A. We know that the SI unit of power is watt and the SI unit of area is meter squared. So, we get to watt per square meter. Therefore, note it down that we have two equations for sound intensity. I is equal to E upon A into T, or I is equal to P upon A. And we have SI units like joule per square meter per second or watt per square meter. Mostly, we use this SI unit, watt per square meter, for sound intensity. Now, understanding sound intensity at different points from a source. Let's consider a point source S produces sound. We know that sound waves or sound energy spreads in a spherical way in all directions as they move away from the point source. Now, I am interested to find the sound intensity at point X and at point Y. Now, sound intensity at point X is I is equal to P upon A, and also sound intensity at point Y is I is equal to P upon A. Now listen carefully. Sound energy or sound waves spread in three-dimensional ways spherically. We know that the surface area of sphere is 4 pi r squared. So the equation of sound intensity at point X can be written as I is equal to P divided by 4 pi r squared. Also, the equation of sound intensity at point Y can be written as I is equal to P divided by 4 pi r squared. The distance of point X from the source is r, and the distance of point Y from the source is also r. Now, according to this equation, intensity is inversely proportional to the square of radius. The distance or radius r of the point x from the source is small. So the sound intensity will be high at point x, while the distance or radius of the point y is large. So the sound intensity will be low at point y. Thus moving away from the source means larger radius. Larger radius means less intensity and vice versa. Therefore, remember that sound intensity at point x is high and sound intensity at point y is low. Finally, let me teach you about different intensity levels. The minimum sound intensity or lowest sound intensity human ear can hear or detect is I0 is equal to 10 raised to the power negative 12 watt per meter squared. Secondly, the maximum sound intensity or highest sound intensity human ear can hear or detect is I is equal to 1 watt per meter squared. Thirdly, the sound intensity 1000 watt per meter squared can rupture or destroy your eardrums. This was all about sound intensity.